Well, first of all, everybody, welcome. Thank you for making it tonight. For those of you who don't know me, I'm Russ Emerson, and you may have known me. Some of you were already thinking I was still with Sitecore when you walked in. I was there for 6 years. Moved over to Rackspace about 10 months ago. Part of the allure of that was to be able to work still with Sitecore and the partner community. So I'm really glad you're all here, and we're going to have some interesting stuff tonight. So I'd like to introduce Marty Stanton.
Thank you, Russ. Hello, Marty Stanton. Really happy to have you guys here today. I wanted to try to help Rackspace give back to the community. I support customers who leverage Sitecore, and it's been one of my most successful platforms of all of my enterprise size accounts. I deal with the larger enterprise accounts that Rackspace has. So when I heard that there was an opportunity to help give back to the community, our company is really big on giving back to the community. And what this building and what this room is about is to help support our geekdom and our incubator labs, help customers and companies be successful. So this is really just our approach, our attempt to give back to the local community and have you guys have a place where you can feel comfortable to have a user group like this, enjoy some food and liquid beverages while hearing about some Sitecore topics. So welcome and thank you for coming. It's very free form. We're really going to turn it back over to you guys to handle for the rest of the evening. And then we do have a racker who's going to come and talk about MongoDB, which we heard from your customers and yourselves that was a topic of interest. So we'd be happy to have a talk about that. But again, very free form. Enjoy the food, enjoy the evening, and let's get started. So I think first we're going to have Alex is going to come up and talk about Pathfinder, and from there we're just going to pass it on after about 35 minutes or so to the next topic, and we'll just go throughout the evening. So again, thank you for coming. Welcome, and let's have a good time.
Thanks, Rackspace, for hosting, and meetups are awesome. Let's keep them coming. Yeah, we have a lot of stuff to share with you. A lot of stuff has happened within Sitecore's world and product department also over past 3 years. So there's a lot of backlog of presentations. Today, I'm gonna share some Path Analyzer bits with you. This presentation subtitles "Sequences Matter," and I hope this sort of slogan of the presentation sort of drive it home. Haven't prepped much. This is my first actual take on this presentation. I just put it together, and it's based on some experimentation with the tool. So it could be a little bit rusty, but I hope you'll forgive me. My name is Alex Shiba. I'm just gonna introduce myself for those that don't know me. I've been with Sitecore for 10.5 years or so. So I've been in QA, customer service, professional services, pre-sales, and finally product. So I lead a boutique Skunkworks team out of US. So I have 3 people on my team, and we're building stuff. Right? Some of that ends up in the product. Some doesn't end up anywhere, just in the presentations. So that's just the nature of the business, I guess. Path Analyzer is a tool that I've been tasked to productize. So I inherited a prototype from about 6 years ago, and the task was to get it, plugged in and released in Sitecore 8. So that was the task. So we primarily focused on the backend side of things, rebuilding that for the XDB, while UI was frozen, and we keep looking into this product. So I sort of became a product manager of it and sort of the go-to guy. So for now, I'm sort of responsible for this product. And the product touched a lot of Sitecoreans over past 5 years or so. So this is not just me working it. I think about 10, 15 people were involved at some point. So I hope you guys will learn something today. Just show of hands, who besides Sitecore people have heard about Path Analyzer and actually seen it in action? A few folks, okay. Any real hands-on experience besides just playing around, actually using it and extracting value out of it? Okay, perfect, great audience. Nobody. completely useless product. No, that's. I think at some point the ball was dropped at the knowledge handover phase. So I know I haven't done a great job sort of transferring the knowledge from the team outward. So, but we're working on fixing this. And Eric, thank you for helping out in that. I think you guys will be seeing a lot of cool walkthrough videos coming out soon. So today I want to just go through basic things, what Path Analyzer is, what it's based on. It's based on XDB. So we have to cover a little bit of XDB so you guys, we are on the same page. We're going to see how it works in a nutshell, and I have a pretty cool demo, I think, lined up for you. So it's not just slides. Since I have about 30 minutes, there's a lot of ground to cover. Let's just jump in. XDB 101. So Path Analyzer is a component that's built on top of XDB, and XDB is an evolution with a revolution somewhere in between from OMS, DMS, DMS2. So it's sort of our place to store all the experience data. You can think about it this way. It's much more than that, but for the context of this presentation, let's keep it simple. So imagine this is just a storage to persist all of your interactions, visits, contacts of visitors, and all the additional data that comes with it. It's a pretty rich data model that's stored within it. It's implemented in MongoDB, and it comes with a homegrown MapReduce process that sort of takes the data from XDB and aggregates into SQL for reporting. So you can consume it in a very efficient manner comparing to DMS and previous OMS implementations. Again, very much just the basic overview. There's way more to it than I'm showing today. A big part of that is ability to store model and interaction, which is a visit, but it could be online or offline interaction, so it actually supports both models, but think about it as a visit, right? So let's take a look how visit or interaction, I should refer to it as interaction, how it actually modeled and what's inside of that interaction. So every session, web session on the website essentially produces interaction. And interaction consists of pages. You may visit pages, right? It could be one page or more. Within each page, you could have one or more page events or goals triggered. So that's just in a nutshell what interaction is, right? Every interaction has to have a contact associated with it. So this is actually a visitor that engages, that actually performs that web session, goes through the web session. Interaction has some metadata, so some attributes such as engagement value, start date, language, browser, GeoIP. We have to describe interaction. So, right, and pages have the reference to Sitecore items, which correspond to every page, right? And within every page, we have an optional collection of events that were triggered in the page. So if a goal was fired, a registration goal was fired on the register page, we'll be able to see that within this model. So that leads us to sort of this set of questions that we may want to answer, ask XDB and hopefully get an answer, right? What are the most visited paths, right? So we're asking all the questions, and you guys read it much faster than I can talk. All these questions in terms of sequential, they all of sequential nature, right? We're talking about paths that lead to a particular goal, right? Okay, we got all these paths, but which are the ones that are most efficient, that get you the most engagement value per visit? They may not be the most visited paths. So kind of interesting opportunity to steer your visitors towards that path that works and get more engagement value, registrations, purchases, whatever it is the case for your business. You may be losing some visitors. Like we've seen some cases where a sequence of visit from email campaign produces not found, so folks hitting some broken links for email. You can immediately spot that and react on that. Folks may be going to the paths that you don't even know existed on the website. So a way to sort of understand the behavior of your visitors, how they engage with your brand is pretty important. And path analysis, it's a way to answer these questions. The last one is interesting as well. How do you know how exactly folks get from A to B. If you have a landing page, you have some target page, you can extract that information from XDB, but would be nice to have all these answers right on the surface in front of you, right? Now, this is a piece of Psycho.NET story. It's a pretty old story, and I've been told hundreds of times, and I think this is not exactly the original story. It morphed, right? As usual with stories. So when we plugged in the original prototype about 5 years ago, maybe more, we've learned on Psycho.NET, the old version, that folks that went through products section and actually got exposed to our products, what Sitecore is all about, they were converting on a much higher rate at the demo request form than the ones that were hitting demo requests from the homepage. They didn't know really much about Sitecore, not a lot of context. So we saw that some people actually signed up for the demo, but the rate was not as high as folks that went through the product page. Right? And you can imagine, this is sort of a cute scenario, right? But you can imagine a lot of similar ones. And path analysis, sort of a way to answer these questions. So with Path Analyzer, we build a tool that focuses on the sequences of XDB data elements, right? And what I mean by XDB data elements is not only pages, it could be interactions of page events that get triggered, interactions, sequences of pretty much anything that comes out of XDB. You can extract that, build a sequence, and put that into Path Analyzer and visualize it, analyze it. So that's pretty much the idea. It's based on a abstract sequence analyzer component that allows you to build these sequences of anything. You can even get external data, let's say your orders from e-commerce, plug that into there and build sequences of orders, right? And figure out how folks actually, what their journey is with your brand, what they purchase, maybe spot some interesting patterns. So it is a feature available in 8.1 and greatly enhanced. Sorry for the typo. Has to be a new word. Enhanced in 8.1. It's built on top of XDB, as I mentioned. Its primary use case in the product is to analyze page sequences. It essentially builds special tree structures in memory. This is a little bit technical, but it's important to understand how this actually works, because at the end of the day, everything's stored in the reporting database and it's consumed. So there's an API that lets you access all of these trees that are stored for you, so you can query it and do some analysis on top of that. So what we do with Path Analyzer is pretty much can be extended with any sort of analysis you want to put on top of these tree structures. So there is an API to access it, and you can do pretty much any sort of analysis you'd like. As I mentioned, built on generic sequence analyzer, and it is an extensible piece of our marketing platform. So this is one of the differentiating factors between Google's behavior flow. You cannot really take control over how these sequences are built. So if you have some external data to integrate with, you can actually use Path Analyzer as a way of sort of analyzing all that data in a sequential manner. So it's a unique value prop, definitely, of this product. So we talk about sequences, but let's take a look how the magic happens. There's really nothing crazy to it, but this is a patented technology. So Sitecore has a patent for it, which is pretty cool. I guess if you like patents, if you think they're cool. It's based on the notion that you have sequences of these elements, which are pages, and you can sort of group them together, you can build trees out of them, right? And you can aggregate key metrics such as engagement value, visits, and additional metrics, and start analyzing the structure as you analyze conventional trees in computer science, right? So let's imagine we have 4 interactions that we're processing from XDB. One interaction, just home, visit home, and exit with 0 value, it's a bounce. That's how we will represent this tree. and path analyzer. So we have a root node, which will always needs to be the case. So every page will have a node, right, with a set of metrics. So in this case, home root, pretty boring. And color will describe value per visit, value divided by visit. So this is efficiency. So this is how efficient your paths are in generating engagement value. So the tool is pretty much geared towards that problem. Now, they signify the value at the end of the sequence. So you can track. When we have an aggregated tree, we need to figure out which parts of that tree would actually had exits, right? Because all the paths are aggregated. It's difficult to figure out, as you'll see here, because of the exit could happen at any level. You want to find paths that are sort of terminating paths. So this is sort of a marker to say, okay, this is the number of times exit happened at this particular path, right? Like in this case, this is a second interaction, home product special request demo with exit value of 100, right? Now the path becomes green because we have engagement value. It means these paths are pretty efficient. I mean, this is just one visit, so we have efficiency of 100 on these paths, right? Because we had home in the previous interaction and we have 2 visits here on this level, efficiency is 50. That's why it's less green than the other path. Does it make sense? Because we glued all paths together, right? Then we continue to the third interaction, home, about us, news, right? So we have home is our shared page, right? Everyone starts with home, but then it sort of diverges here. And then about us and news, this is a red path because it exited without engagement value. So immediately we see a path where, hey, we're not getting any value out of it. So we may want to take an action out of here, not based on 3 interactions, but based on maybe a few thousand interactions. And then there's the fourth one, lending products request demo with engagement value of 100. So we have now, we can see that products, folks that go through products areas, these paths are much better than any other paths. So in this way, we can see all of the metrics getting aggregated at this level. So the root has 4 visits, but the efficiency you can see drops to 50 because we have total only 200. And these paths have efficiency of 100, so top efficiency. That's why they are green. So immediately we can see the best paths. We can learn from it, and what we can learn from here that folks going through the product section convert to request demo much better than any other paths. Yep. For that sort of hectic interaction, there will be a lot of noise because we're gonna store every trip to the home page is gonna be produced as an element of the sequence. So, but usually on the grand scale, if you analyze like a few months of data, you can put the significance level. So we can actually discard all of these garbage data, less significant data, focusing on the more important stuff. This is where you'll be able to see patterns. The idea is to give a human a tool to spot patterns. We are still pretty good at that. But yeah, it is the noisier your sort of journey is, the more difficult it is to analyze. There are some ways to look at it. There is a tool that looks at it from the page perspective, so it sort of groups everything and builds paths around a particular page. That's helpful, but yeah, we've seen some of that. But usually the number of visits for these paths insignificant comparing to direct traffic. But you got to really be reviewing what's in XDB, what kind of sequences are there could be some stuff from ASP.NET sometimes. I mean, if you're not triggering your events properly, your page events properly, you may get some undesired page visits in there. So you really have to have a clean XDB model in order to get the most value out of it. Yep. Yep. hmm So that value will be associated with the whole interaction. We don't associate value with pages. So if it's a messy interaction, that same value is applied to every page on that interaction. But it's an interesting point to be able to sort of streamline the sequences a little bit at runtime. That's something that we're thinking about, the additional post processing of this data to get a little bit cleaner. Definitely value in this. hmm Yeah. Uh, there's definitely, yeah, absolutely. So that additional post processing, because all those trees are there in the storage, we can run any algorithms on those and potentially sanitize them. We yeah 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 yeah. It's a really good point. Some of the stuff we're working on A2, there might be an opportunity to do something like that. We'll look into that. So let me do a quick time check. So I think we are sort of at the half of the presentation. I think it's time to start showing you some demo. I think slides are cool, but yeah, to a certain point. So here I'm proposing we'll turn on our imagination, and we'll imagine that we are a head coach of an NBA team. Right? Kind of weird. It's like, where are you going with this? From Path Analyzer to NBA. You guys watched the game last night? Warriors game? Complete destruction. 30 points. So I'm not implying that Luke Walton and Steve Kerr, they using Path Analyzer to win the games, but it's more like wishful thinking. But let's imagine that we are the coach, and we're looking at our XDB as a way to represent a model of the game, right? So here on the left we have completely messed it up. So ignore the first line. So on the left we have ball possession. It's a element of a basketball game. I bet everyone play basketball, at least understand basic rules, right? Possession can lead to a score or it may not lead to a score, right? We have players who made shots, they miss, the rebound. We have outcomes. So this is sort of the orders here messed up completely. So the idea was to show you correlation between what's in the game and what we have in XDB, right? So ball possession, think about it as an interaction, right? An interaction that could have engagement value. So if at the end of the possession, player scored, we have engagement value. Kind of basic, right? Within the interaction, we have pages. So players engage in the ball possession, right? So that's the correlation here. Made shot, that could be a goal that we can track, right? Miss, rebound, these could be page events. Win or loss could be outcome. We also have on interaction have a channel. So this is way like email, online, social channel, right? So we could track maybe it's a home team or maybe it's a away team. We can treat the channel like that. So we can analyze game data in terms of channel, whether it's a home game or away game. And it falls into the place really nice. So imagine we can describe a sequence of a ball possession as an interaction where one of the goals we'd like to achieve is to express a lineup of players as a sequence, right? Because we may not have the data to describe passing, right? So some players may not be fully involved in the possession, but the fact that they're on the floor matters for our problem, right? So our sequence, the way we describe it, is 5 players. Last time I checked, 5 players were playing for a team at a particular time. And we have 2 special nodes at the end, right? Assisting player and a shooter. So if shot was made, somebody made the pass. It's optional, but let's imagine it's there. So a sequence like that will let us first look at the lineups, right? Starting lineups, see which lineups actually perform better than other lineups. If we use score as a way to associate with the interaction, the way we handle engagement value, then we'll be able to see the most efficient lineups as well. So what we're gonna do, we're gonna get the CSV file with play-by-play data, which is available for $20. You can download it. It's amazing. Down to every second, you can see who had the ball, right? We're gonna map it to map different models across these 2 domains. So our interactions in XDB, they will become ball possessions, pages players, scores page events. We're gonna need to create marketing definitions such as goals for every of the goal that we'd like to track, right? And we're gonna finally load it into PsychoXDB, which is custom scripting. Pretty easy, really. Nothing to be excited about. But I think the result, because we load it in XDB, automatically becomes a part of that data set, and Pathanalyzer will start building data for you. So you don't actually have to customize anything within Pathanalyzer to extract value out of it. So let me show you the result out of that. I'm gonna skip the part where I'm writing a script, right? And I'm just gonna show you the result. This is a Psycho instance that I have up and running. Pathanalyzer is available on the Launchpad. The moment that data is in XDB, Pathanalyzer becomes aware of the new data and will start crunching stuff and building that in a reporting database. You don't have to do anything there. So we're gonna go and we're gonna launch this application. We're gonna select a default all experience map. This is the map that shows all interactions that are not filtered, not segmented for a particular day. So what I did, I loaded a data set from a game, Golden State Warriors against Sacramento Kings, where we won big time. And I did the modeling as I described in the slides, and this was immediately the result, right? You see, like, oh, some red paths, some green paths, right? So let me zoom in and I'll show you. So this is, the nodes become players. So you see Klay Thompson, Iguodala, Draymond Green, Andrew Bogut, Stephen Curry, obviously. So this was the lineup, and 2 less players. This was the assist, and this was score. So you can immediately see sequences of players that work better than other sequences of players, right? And this is applicable to soccer, to any sports where passing is involved and there is a team, right? And hopefully scoring too is involved. It's kind of important. Well, we can find out. Right. Thank you, Rick. Great question. So these reports available on the right side will essentially do the job of finding the most valuable paths that brought you the most scores, right? The most efficient paths, the ones that brought you most score per instance, per possession, right? Because this is the game set for the whole game, including 2 teams, it may be a little bit too much data. So I built a segmented map only for Warriors, right? So you can see, okay, this is just one team, right? Let's see the most valuable path, including Andrew Bogut, Andre Iguodala, Stephen Curry, Klay Thompson, Draymond Green. That's my lineup, I would say. Um, it's depends on how much they scored, right? Any score. Here, if we enable this panel, not much real estate here, you can see this matrix on the left indicate a value of 6, so 6 points, 10 visits. This is the efficiency. So though they brought the most value, not necessarily the best efficiency. That's why it's not greenest, right? This is the greenest, 0.8 value per visit. That includes Barbosa. That's kind of cool. So as a coach, maybe this could help me figure out, the last minute lineup, whom to sub. Not sure, but the use cases exactly. But I think there's something in there. It's all sequences leading to a goal or an outcome, right? An outcome. If you think about Sitecore's terminology, outcome is this significant event. So that could be a win or loss, right? So we can analyze the whole season and figure out the paths that led to most wins, right? The more data you have, the more interesting it becomes. But you can also spot some interesting stuff like addition of some certain players into the sequences really messes things up. Like you may find Stephen Curry somewhere here, but then addition of, there was one particular guy that was messing things up. Let's see, let me zoom in a little bit. Yeah, this Justin guy, Justin Holiday. Let me pull up this page analyzer. So this is the view that shows all the paths around this Justin Holiday guy. And you can pick the particular paths. You can see a lot of red paths around this guy. May want to think about. But one path is particularly interesting, where he, I think, passes to himself or something, because he's present here multiple times. I don't know how to interpret this. But you can see, maybe you learned something you didn't know before, right? Maybe not. I'm using this to just to explain sort of path analyzer concepts. I cannot close this window anymore. Oh yeah, there you go. And some of the concepts involve segmentation. So this way, instead of looking at this sort of overwhelming all experience map, we segment it by team. So you can segment by whatever contact criteria you have, particular rule you can apply, and have the map describing mobile visitors in Sweden, right, that engage from a particular campaign. So you can do that as well. Also, since we talked about goals, let's imagine a map that shows only interactions that led to a shot, right? So here I have the special map created that is built around shot being goal, right? So in this case, we can see only sequences that led to shot was made, right? And analyze it this way. So since we don't have ability to do this runtime filtering, the way to do it is to set up a map for that particular segment. If it's a goal map, see you see shot here at the center, and you see all sequences of players that led to the shot, and you can analyze the map in this particular context. We also have this experience map. Experience map looks at path analysis from more like macro perspective, so not individual players, but more channels and goals that are triggered here. So let me show you. Here we have starting node. We have home, which indicates home team. We have away, indicates away team. Next node indicates events: rebound, miss, foul, assist, and shot. So these are sequences. These are shots made without the assist, which can happen. And these are sequences that led to assist and then shot. So you can look at the game from that perspective. Okay, which events led to which outcomes. So this is away team, and this is home team. We can see fouls here. Metrics will indicate for each node, indicate how many fouls happened, right? How many rebounds. So a way to sort of engage Path Analyzer on this macro level. For online marketing, imagine looking at a sequence of channels, campaigns, and goals, right? If you're not interested in concrete pages, right? There will be less noise. There will be you will see a clear picture which channel led to the most conversions or higher efficiency, right? Finally, because I'm running out of time, I want to show you custom gameplay map. Because Path Analyzer has this extension point that lets you define, as a developer, define the sequence yourself. So the recipe of how your map will be cooked is sort of up to you. I'm using this particular technique to show this gameplay special gameplay map, where instead of showing the whole lineup of players, I'm only grabbing the last player that made the assist and the player that made the shot. So sort of focusing on that. So here we can see way less data to make sense out of. Here you can see Stephen Curry assisting to Clay mostly, kind of interesting. Then to other guys as well. And this is just single game data, right? Then you see Ezeli here shooting by himself without any assist. And metrics on the left side will show you how many of those occurrences were, right? Only one visit, so means only once most spades pass to Ezeli here, right? And it's just a little piece of code required for you to sort of define that recipe. You have full access to what's in XDB, and you as a developer say, okay, I need the sequence to be built in this way, right? It's definitely not super marketing friendly, but any Sitecore developer can do that with ease. Let me see what else is out there. I think that's pretty much it. There are two goal maps. One is a reverse goal map. Another one is a sort of traditional goal map. So if you want to see all sequences lead into a particular goal, and it sort of have the sequence be reversed, right? You'll be able to create a map with a reverse checkbox, and that map will be reversed for you. So instead of sort of focusing on at the center here, there will be the goal that you're analyzing. I think that's Path Analyzer. I have just a Q&A slide there, so if you guys have any questions. You could, the recommended way would be to extend XDB itself and do that via that, because the tool is morphed in 8.1 a little bit, so it was more of a standalone, just you can push anything into it. In 8.1 is very much accepting XDB as a source primarily. So as long as you extend XDB, which I did by just importing the data, right, you can harvest that within Path Analyzer as well. So if you start storing something on the interactions or on the context, you have full access to that. It will involve basic extension customization, but it's very doable. The only I did create items for each player just to show the label of every node, but you don't have to. No, no. It's much easier to extend XDB, and especially contacts. Contacts are built for extension, but interactions not that easy. But adding new facets into contacts with CRM data, you'll be able to segment maps on that. So if you have like membership model, you can augment the contact with the membership data. Then you'll be able to build maps for gold, silver members, for example, right? That's pretty straightforward. It's all based on the rules engine, so as long as you can have a condition there, it's up and running. Any other question, guys? Path Analyzer. Let's start using it. Thank you.
Hey guys, so my name is Adam Brill. I'm a co-founder and executive vice president of Hero Digital. I mainly lead the .NET efforts at Hero, as well as help drive the Sitecore partnership, and have led a lot of Sitecore implementations for companies like TXU, Stream, Nerium. Many of these projects have turned into multi-year projects that we've worked on, and they have a lot of deep integration points. So here's the agenda that I want to run through with you guys today. I'm going to start with just a bit of an introduction to Hero, and then talk through some of the challenges that we had while we were implementing the email experience manager, and talk through a bit of how the contacts and list manager work, because it kind of affected me a lot. And then go into external data sources of kind of a unique use case of something that we needed. So the first thing is just Hero Digital, and we try to focus on the entire customer experience. And the way that we define the customer experience management is really to create a personalized experience that matches the right content to the right user at the right device at the right time. And we do that in order to help marketers tackle the biggest CXM challenges that they have, which is to integrate all of these experience channels that you see across the top here and provide the best experience on each one of those. And today I'm going to focus mainly on the email side, but as you guys know, Sitecore can really provide a great experience across web, mobile, commerce, social, and products as well. And to do this well, we think you have to think holistically and bring together a range of skills. And there's kind of four main categories that need to work together well to deliver for each customer. And we've done this for some really great clients. Today I'm going to focus on Stream, which you see here on the middle left. And I'm going to focus on Stream just because that's the company that we integrated the email experience manager, and I just find walking through real scenarios is the best way to learn about these things. This is a bit of the foundation of our .NET expertise. We have about 25 engineers across our .NET team and have worked on a number of large Sitecore and .NET projects over the years. We deliver for a lot of clients nationally. Our headquarters is actually just down the street from here, just on Post. I actually lead our Los Angeles office, and we also have a satellite office in the Boston area. So I want to introduce you a bit to Stream because just to give you a bit of background on the company. And when we started working with Stream, they brought us in to expand their business both geographically and their product lines. And when we first started working with them, their sites were very silos. They had about 3 systems that they used mainly to manage customer information, and all of it was very disconnected. And what that led them to is that you got one experience when you went to one platform, and then as you went to the different platforms, you got different experiences, but the customer didn't know the difference, and it was just kind of an odd experience. So what we were trying to do was bring all of that under a single umbrella, and that umbrella was Sitecore. And when we engaged with Stream, they had a very aggressive timeline. We launched their marketing site. From engaging with them, we launched their marketing site in about 3 months. About 3 months after that, 6 months after we started engaging them with them, we had rebuilt their enrollment funnels and their portals. And at 9 months, we had introduced a whole new offering, which was mobile service. So the first thing we did was build their marketing site, and we built this with personalization in mind, of building the best experience of letting the marketer actually make decisions based on the customer that's browsing the site right now, and letting them customize those based on the user location and things like that, which was particularly interesting for them because they offer different services in different geographic areas. So being able to hook all that up was very valuable to them. Yep. We did on this. We did on this one. The CIO brought us in very early. They didn't even select. They hadn't even selected the content management system. They knew they needed a platform, but that was basically the place that they were at when we engaged with them. And so we got in there, understood their needs, and then recommended Sitecore and built the whole thing. Yeah, and we did a lot of the design work for it too, and laying out the site. So the next thing that we did then was to build the enrollment process, and we did this with a using like a cart model, because there were a lot of different products that they were offering, and we wanted to make it as easy as possible for customers to purchase products across their different channels. And this is just kind of, these screenshots are kind of walking through a bit the process. You can choose your phone, configure it, choose the data plan, add it to your cart. Then we have upsell opportunities where you can add new of your energy service or insurance services to your cart. And then through a single checkout process, you can go through the system and land on the confirmation where your accounts are actually created. And behind the scenes, this could have communicated with 3 or 4 different backend systems, but it's all under Sitecore, and the system or the customer doesn't know the complexity of the whole system. They dictated that. They had a commerce engine for one. They had a homegrown, 2 homegrown solutions. It was a pretty big mess in the back end. What's that? Yeah, yeah. So then the next part that we moved to, once you had an account, we created an online account for them, like a portal for them to manage their account, which I'm just kind of going to walk through here, just a couple things really quick. Really, it's just kind of to be able to see your usage, manage your account, pay your bills, things like that. This is a bit of just the technical details of how we delivered for Stream. And the core of it was all around Sitecore and letting Sitecore personalize all of the content and handle all the display logic and multilingual capabilities. But then we built it with a multi-tiered solution so that there was a middle tier that was built that would connect to all the various backend systems and sort of abstract away the difficulty of working in their systems. So enough about Stream. Then this is the kind of some of the challenges that we had integrating the email experience manager into Stream. And what we were trying to do was basically build them an email template. And that email template, we wanted it to be able to use the same items that they used on their site. So they could actually, the email template the message editor that you're looking at there on the right will let you build out emails in basically the same way as you build out pages in the experience editor, which is very easy for the marketing team to use. They loved it compared to, they had been using a variety of different email builders, and it was, they loved Sitecore's ease of use on it, because all they really had to do was just pick the different items that they wanted to render, and it would build the email for them and they could send it. And we did that. In this case, this template that you're looking at here was mainly to promote a blog that they write. And we did that by just using the same blog post, and we just made a different rendering for the emails to render like an email friendly version of each blog post. And then you could just use the experience editor in the email campaign manager or experience manager to build out the email and send it. So that part was actually relatively straightforward for us to build out. We didn't have many difficulties there. And like I said, the marketing team loved it, and it was significantly better than the system that they had used before. Yep. Yeah, it was an opt-in. They had a list of about 40,000 contacts that was actually, I'll get to that in a minute here, actually, next. The contacts, there were about 40,000 contacts that they had in a different external system, and they couldn't move that into Sitecore, which was actually one of the bigger hurdles that we had to cover to use the email experience manager, because by default, the email experience manager just works with contacts that are inside of Sitecore. So that was basically the second point under contacts. The second one was just the way kind of contacts worked inside of the cloud environment. So I won't dive into too many details there, but there's some complexity of working with the contacts in cloud environments specifically, and I'll cover a bit more about what I mean by that in a minute. Then performance was another thing that we initially had a problem with. The first time we tried to send the email blast to 40,000 people, it took about 8 hours to send, which was a lot longer than they were okay with. And yeah. So we spent a little bit of time performance tuning, and really it didn't even take us that long. It was about probably a day of performance tuning it and testing it, and we got it down to about an hour to send 40,000. And that was basically all that we did was tweaked caching and enabled multi-threading. And those are we didn't really have to do much more than that for Stream. They were happy with the hour to send an email blast. That being said, there's a lot more that Sitecore will let you do. You can spawn up additional servers. You can have different rendering servers that are actually sending it. You can have as many different agents sending the emails as you want. So it's very scalable.
Was that using Dyn?
It was. We used Dyn, yeah.
What do you mean by rendering?
So each of the emails are actually rendered like a normal page is inside of Sitecore. So it'll render each email for each customer.
Yeah.
So then some server has to render each of the emails.
Really?
It doesn't have, it was in our case.
Server,
Yeah.
but
You can configure it to use as many different Sitecore servers as you want to render them.
wow. Burn.
I wasn't going to say it.
Tape that?
So some of the other challenges that we ran into, the email tracking, we originally were not deploying the Sitecore folder for security reasons to the content delivery boxes. Well, you have to deploy some of the files because what it was, there's a couple ASPX files that are used for tracking that capture the read, like the open rates and the read rates on the emails. So what we ended up doing was just finding those particular files that were needed and deployed those out to the servers, but still didn't deploy the entire folder. And then all the contacts have to be in the contact manager in MongoDB, like I discussed. I mean, basically they have to be in the XDB in order to track any of the email. Then a different thing, just to throw it out there in case people are hosting in the cloud, kind of a little gem that we ran into was that the renderer URL, which is the default URL that it uses to render the emails, sets itself to the first request, like the host on the first request to the app pool, and from that point on is static. Which we ran into a problem with that because we were hosting this in Azure, and for those of you familiar with it, Azure has a different staging slot. Like the host name is different for the staging slot. So when we swapped it over, the renderer URL stayed at the staging slot, and we ended up with server or emails that wouldn't render anymore. And it took us a while to sort that one out, but it was an easy fix. And then this one, I kind of threw it on there at the end, the custom unsubscribe URLs. Unsubscribe is handled by Sitecore, but as with anything else with Sitecore, it's all built with pipelines, and you can extend anything as much as you want. So we just extended the send email pipeline and added that functionality in. So the EXM contacts and list manager, then I just want to talk through a bit about how they work because it's helpful when actually working with them. And some of this is going to get a bit technical. Just throwing that out there. So the contact data is all stored in MongoDB in the XDB. And that's things like the first name, last name, email address, the lists that the contact is in, including all of the paths that contact has hit, and all that information is all stored together in MongoDB. And in the case of contacts, it's actually indexed in Lucene as well. And that data is then used, or those indexes in Lucene are then used for searching the email lists and finding the lists or the contacts that are in lists and things like that. And saving a contact adds it to a queue that Sitecore then uses to re-index that contact and add it into the Lucene index, which is important because what we were running into, that Lucene index was actually stored on disk, but we were hosting it in the cloud. So when we respawned the servers, we would lose that index and ran into some issues with that one. The lists then are stored inside of the Sitecore database, and that's things like the list name, the number of contacts that are on a list is cached there, as well as a variety of metadata is stored with each of the lists inside of the Sitecore database. And the contacts are, like I mentioned earlier, the contacts are linked to the lists in MongoDB or in the XDB and in Lucene. Which means you kind of have to have those matching up in order for the contacts to work properly, which again is mainly an issue inside of cloud environments where you're respawning servers with a click of a button. If you're not respawning the servers, then you don't run into a lot of these issues. The list IDs then are indexed as well as part of Lucene. So basically, if you don't have that Lucene index, you don't have contact lists. Sure. So there's a variety of ways you can solve it. The way that we solved it is through modifying the pipeline. So the contacts are loaded via pipelines basically the same way as everything else works inside of Sitecore. And what we did is just extended the pipeline that loads contacts and changed it to work the way that we wanted. Basically, don't use the Lucene index anymore. I mean, you certainly could. Yeah. I don't know that it probably would use that. Yeah. Yeah. So the specific problem that I want to kind of do a deep dive into then is the external data sources of how you can do that within the EXM. And there's really two options that we considered here. The first was doing a content sync. And basically what that is just a background process that syncs the contacts from whatever that external system is into XDB. and then you can use segmented lists and either built-in or custom facets to find the contacts that you want. And the second option that we considered was extending the contact pipeline to actually real-time look up the contacts every time the list is requested. And the pipeline works like the rest of the pipelines do in Sitecore, of that you can build it where it'll basically try that first and then fall back to the normal Lucene lookup for any lists that you don't want it to work that way. And this would work basically with any sort of list as well. It just uses, the lists are built, the contacts are built with just an iQueryable in .NET, so you can build any implementation for iQueryable as you want. It's a concern. Next slide. Performance issues on the bottom right there. Yeah. So the first option of the contact sync, the pros for it is that it integrates better into the lists, because it's actually, once the contacts are in XDB, you can work with it the same way as you would any other contacts. And the contacts are pulled directly from the contact manager. So you basically, it's kind of a one and done with that sync process. The cons to it is that it still uses the Lucene index. You have to monitor the sync process at that point to make sure that it doesn't quit working and you don't notice. And possibly most importantly, if you care about your contact list being up to date constantly, it's always going to be slightly out of date if you're running any sync process. The second option of building the pipeline, it worked better in the cloud for us, and you can sort of use a combination of these two options too, and that's kind of what we did. And the list is up to date immediately. The cons to it though is that it requires the link to the external system to be up all the time. So if the external system goes down, then EXM goes down, which is not great. There's also, a higher likelihood that you're going to run into issues at the time of upgrading Sitecore, and performance issues are a very real concern. Of this gets hit a lot. And it's the Lucene provider responds in milliseconds. So that's basically what you're up against of trying to get it to respond. That's basically what we ended up doing. Yeah. So I'm actually going to jump over and show you guys a bit of the code example of kind of what that looked like. If I can make this actually readable. I don't know, can you guys read that? Sort of?
A little bit more, please.
Much.
Yeah, that's cool. I mean,
maybe that's okay. Yeah. There we go. So this is basically the sync process that we built, and what it's, just to kind of show you how this is connected, then it's just running like any other scheduled task would run inside of Sitecore. Currently, I have the sync process running once every minute, which is not probably how you'd want it to run, but for this case, I set it that way. You could basically run it as often as you wanted to. And this is not incredibly straightforward about how to actually work with. There's basically two different objects that you have to work with contacts, the contact repository and the contact manager. And it's not documented that well out there. It's around, but it's a bit challenging and difficult to find. So I'll kind of just walk through the process of how it would work. And if anybody's interested in seeing any of this in more detail, I can definitely give you access to the Git repository or whatever if you want. Yeah, sure. So then walking through this, then what we're doing here is basically just loading out all the contacts from SQL. And this is somewhere where you'd actually want to add performance into the sync process if you'd want to keep track of the contacts that have already been synced and or haven't been modified, and not sync them every single time. In my particular case, I wasn't working with a large enough data set that it just didn't really matter. So
Can we go back up?
sure.
Hey, Alex, does this work?
This is just .NET.
No.
Right. This is just a .NET.
Context.
This is just the .NET SQL library. It's not Sitecore stuff at all. Yeah.
All right, got it.
Yeah.
Never mind. Ignore it.
So then we basically just loop each of the contacts, and I created this method that'll basically just get or create a contact, and it and then opens it for writing. And if that fails for any reason, then in this particular case, I just continue. Again, you can kind of handle that however you want to. This then is the facets of how you can work with facets inside of the contacts. And you can write your own facets as well. And this is basically how you can extend a contact. And any of this then works with segmented lists, where you can use those segmented lists to pull out contacts based on the values that you saved into the facets. But these two facets are actually just built in. So basically all that I'm saving here is just the first and last name, as well as their preferred email address. And then once you get to the bottom, you basically, once we've set the values that we want, we just take the contact manager and we flush the contact to XDB, which is basically what saves it into XDB or the Mongo tables, and then save it in the contact repository as well. And that's basically all that you have to do to sync a contact into Sitecore. So it's actually pretty straightforward and easy. It's just not out there that much. So like I said, I'll definitely make this available to anybody who wants it. The one I'm loading it from, it's just to simulate an external source.
I mean,
You'd-
context, aren't they?
Yeah. So that contact table in SQL Server is a custom table I created just for this example.
I got you. All right.
Sorry. What's that? Yeah, right. It's to simulate as easy as possible just an external system. Yep, right.
That's cool.
Yeah. So that is basically what I had. Any other questions that I can answer for you guys? Sure. It was used. It was used because they had a system that they already had their contacts in, and it wasn't possible for them to just move the whole list into Sitecore and manage the list there instead, because they actually have the list that they were sending these emails to was actually like associates or people that were connected to the company. So that was handled through people that signed up through a variety of different processes, and it wasn't all going, like, you could just call the company and add your name onto the list. So it wasn't going through a Sitecore channel that we could just move the list into Sitecore. Yeah. Yeah. That was a yes with a strong maybe behind it. It's just I mean, you don't have to. You can use any data source. Yeah. Right. I would want to make sure that that sync process keeps track of the contacts that have already been synced, so that you're only moving deltas. Even in the 40,000 range, it actually wasn't that big of a deal for us. I mean, the task runs for a while, but it's pretty fast to just check to make sure that the contact is there. So then the process, we didn't actually run into too big of problems with it. But that's basically what you'd want to do to boost the performance of the sync process. And then the contacts themselves inside of Sitecore can be a lot bigger than that before you're going to have a problem with the list size. Not for this part. You'd need more for sending the emails. Yeah. Even millions, I mean, the 40,000 would import in, like minutes to an hour. Yeah. Right. An insert to MongoDB is pretty fast. Yeah. Yep.
Can't be on the same server.
I think it would depend how often you'd want to run the sync process. Because what I would generally try to do is run the sync process in the middle of the night when you don't have many people on the box, and then it can process that when there's very few people using it anyways. Yeah. Right. By default, that works. That ties off of the email address inside of Sitecore, but you can actually use anything you want. So you could use the external data source ID if you wanted to keep a contact actually linked, like strongly linked to the contact in your external system. But by default, Sitecore uses the email address. Yeah. Okay, sure. You can. They didn't actually want to do a lot of that, but it's all there. You can basically, that's why it renders each email individually, so that you can get that added functionality of it. Actually, it renders each page the same way as, or you build out emails the same way as you build out pages in the experience editor, if you're familiar with that. So you actually, while you're building it, you have the options to personalize, and you can choose based on any facets of the contact. Or I mean, you can go to any level you want. You can even make API calls to an external system for each contact. Might slow down the rendering of the email a lot, but it's there, so you could. Yeah. Any other questions? Yeah. Um,
That's what I was trying to get at.
no, but I would want to basically. So actually, I'm curious as to why this was built using the way that is built now. So I think it actually would be very interesting on the pipeline side of loading the contacts for a list to go directly to Mongo, which would mean that to do that, you'd have to add some indexes into the Mongo database. But Mongo queries like that are incredibly fast. So it'd be very interesting, and actually something that I was considering building out as a module, because for people that are hosting stuff in the cloud, especially, it'd be nice to be able to bypass the Lucene. Because it's all connected to XDB. So you can actually, these same contacts, when you send out an email, it stores the contact information is stored inside of XDB. Then the email gets sent, and it actually, EXM will add on its own parameters onto every link inside of the email, so that if a user clicks on any of those links, it can actually track that contact back and then get into everything Alex was was showing. So you can actually track that back then to an email campaign and
Adjust the email campaign.
Right.
Performance improvement.
Yep.
Response rate.
Right. 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 Mm-hmm. Yeah. Yeah. I mean, a sync process would be, you could build it however you need to integrate with your external systems. So, but you do, with too deep of integration at that level, you do risk an issue when you go to the upgrade paths and things like that. No, we didn't, because it wasn't a use case for us. But you absolutely could. And something like that would actually be interesting too, because you could build that abstractly, so that the integration from Sitecore into that could be built once, and then that could just be configured to connect as many different directions as you want. And it would be, if you had more advanced needs, that'd probably be a great design. Yeah. Cool.
And all of this is being recorded as well, so we'll be sending out a link to all of the presentations today later on. So I'd like to ask a favor of Peter while I'm stalling, while you get Derek on the phone or on the video. I appreciate that. But all of the stuff that you guys are talking about is very complex. And just real quick, while they're setting this up, where we try to find the right niche for the Rackspace team is all of the infrastructure and all of the servers, whether they're cloud-based on Azure or cloud-based on Amazon or cloud-based on OpenStack or a private cloud on VMware. Those are all the components that we take care of, so you guys can focus a lot more on doing all of that coding and all of those kind of complexities on the application. So when you're really looking for those complex environments, we consider Sitecore part of our critical application support group of services that we offer. So all of that stuff that you're doing, we layer 100% SLA on top of it, of the application, and are making sure that when the future patches and all of those things come out from the operating system all the way up through Sitecore or MongoDB is taken care of. And so that's just kind of to show you a little distinction between what a systems integrator is doing versus a do-it-yourself shop. Is we're trying to find that happy medium to let you tie into all those various capabilities and make the Sitecore application as stable and so that it never goes down. So with that, Peter, do you want to do an introduction for Derek or pull him on?
Sure. So I'm going to go ahead and share a presentation here. Hopefully this will work. Let's see. Okay. Can you all see these slides? Yeah? Okay. I think that was a yes. So I'll continue. Okay, cool. All right, so I was asked today to talk to you guys a little bit about MongoDB, just kind of a basic intro, some general information about the database. A little bit about myself first, however. So I'm a solutions architect in our data services group at Rackspace. And so what that means is I work with Mostly next generation data stores. So I work with Mongo, Redis, Elasticsearch, Hadoop and Spark, Cassandra, and I work with our products and do architecture designs around those products for our customers. So my background actually originally is in software development. I was a research programmer at the National Center for Supercomputing Applications in the Security Directorate. I spent some time in the Army as an infantryman, and I spent some time at Blizzard as a game developer, but then landed at Rackspace and switched to more operational roles for a while. I was an enterprise lead engineer at Rackspace for a while, and before I moved over into the data side of the house. So that's just kind of my background. I think it's important to kind of know where somebody's coming from when they're telling you information. So let's start with the basics of Mongo. And probably the best way to understand the basics of a technology like Mongo is to ask the people who create it what it is. So if you ask the folks at MongoDB Inc., formerly 10gen, they will tell you, excuse me, and this is from their materials, that it is an open source, document-oriented, NoSQL database. So let's just break that down. So first, the open source piece. I think, as developers and users in the tech community, we're all aware of what open source is. MongoDB itself is under the Affero GPL license, v3, which is basically a version of the GPL v3 that's a little more geared toward network software that may be hosted. It was the AGPL is sort of designed to close some loopholes for service providers. So but it's essentially the GPL just for that specific sort of software. Document-oriented. So MongoDB is one of several types of NoSQL databases over there, and it's a type that we refer to as document-oriented. I'm sure you are all familiar with relational traditional databases where you've got things like referential integrity, primary keys. You may choose to array your data in one of various normalized forms. I'm sure those of you who are maybe more SQL-oriented or more traditional data stores oriented may think about third normal form or Boyce Codd normal form. Those various levels of normalization where you split your data out into tables that have basically the minimum amount of information for that particular fact, and then we'll link them with other tables, as you can see there in that little relational model diagram. Excuse me. A document-oriented database, however, looks more at documents as a whole. So each record in the database is a document, which is essentially just a collection of values. That collection of values may be simple values like integers or strings, or they may be compound values like like lists or essentially arrays, or even whole documents may be the values of particular keys in that document. So you can see there on the right kind of a document with a few components. You've got an ID, you've got a username, and then you've got a couple of sub-documents. One is a contact, and one is access information. And so you can see how each data member of that document is essentially a key with a corresponding value. But that value may be a simple value or a compound value like another document. So Mongo is one of several databases that takes that document approach. And then, of course, NoSQL. NoSQL is one of those wonderful, amazing buzzwords that we love in the tech community. Probably only second to big data these days as a popular buzzword. But just to break it down, it started out as sort of a backlash almost against traditional concepts of databases. For a long time, there were a lot of different data stores out there. There were NoSQL style data stores, even though we didn't call them that yet. But the market was really dominated by relational databases. And in that circumstance, that meant that we tried to sort of fit everything to that one tool, your classic hammer nail problem. Because relational databases are inherently very flexible because of their highly normalized data model. You can approximate pretty much any data structure within a relational database, but it might not be fast, and it might not be efficient, and it might not be easy to develop for. And so the proliferation of non-relational or NoSQL databases really allows you to make some of those application-specific concessions to your data model. So one of the first key factors that makes something a NoSQL database is that non-relational characteristic. And there are lots out there. There are key value stores, document stores, graph stores, wide column stores. Some people consider to be search-oriented data stores like Elasticsearch to be a separate category, whereas some will call them a document-oriented database. Just kind of depends on who you're talking to. Second thing is dynamic schemas. So again, in a relational database, your schema is generally set at the beginning, and modifying schema can be a real pain if you want to change application functionality, if you want to extend what you already have. It can be difficult. These dynamic schemas of NoSQL databases lend themselves to the agile development methodology in that they make it easier, if not easy, to change things midstream. They make it easy to start developing your application and then let the ideas sort of form as you go, because schema is not set in stone. Individual documents in the same collection, for example, in Mongo, can have varied schema. There's no hard and fast rule other than that each has to have a key, an ID document, or I should say an ID data member. Other than that, different documents in the same collection may look totally different from one another. And so that makes it easy to extend functionality. Of course, it also gives you enough rope to hang yourself with. So that's a common affliction that I see among developers. They're typically distributed, which means you're going to hear words like sharding, replication. Maybe somebody who's really excited might tell you that these databases are self-healing, something like that. But all essentially different technologies that are used to allow them to scale horizontally. And these things are basically the love child of Web 2.0 and Edgar Cod's nightmares, and that's just kind of an inside joke for people who are data nerds, database nerds like me. So as you can see, there is a huge proliferation. I mean, as Hipster Dog told us in the previous slide, just about everybody's decided that it's time to write their own. This is just a smattering of the very most prominent ones. There are many more out there. You've got on here, you've got things like document stores like Mongo. You have key value store like Redis on here. You have some proprietary databases like MarkLogic and Amazon DynamoDB, a graph database like Neo4j. You've got my personal favorite, Cassandra, which is why I put the deal with it glasses on the icon because I love it. So you have a whole wide variety depending on what your use case is. So let's look at the architecture of Mongo specifically. So the basic building block of a Mongo cluster is the replica set. A replica set in Mongo is 3 servers, a primary, and 2 secondaries. Or if you're really trying to skimp, a primary, a secondary, and an arbiter to help with split brain conditions, but that does not keep a complete copy of your data. So in a replica set, each one of those 3 nodes is going to maintain a complete copy of the data. Your client application, via its driver, is going to talk to the primary to perform writes and reads. Those writes and reads are going to be replicated to your secondaries. So sort of a master and 2 slaves kind of situation here. Mongo does allow you to turn on reads from secondaries, so it does allow you to read from secondary nodes with the understanding that there is the possibility of delayed data due to replication delays. So there is the possibility of eventual consistency in that situation. But this is kind of the building block of any Mongo deployment. And in fact, it's very common for smaller Mongo deployments to be deployed just like this. It's actually unfortunately common for Mongo deployments to be deployed on a single server, but please don't do that except for testing. But this is really the building block of any Mongo deployment. So when it's time to scale, when it's time to get all that NoSQL goodness out of it, you have to start sharding. Sharding is Mongo's and many databases' strategy for scaling horizontally. Sharding is done at the collection level, and so a collection is essentially equivalent to a table in Mongo. And so that a collection is going to be sharded based on the hash of the shard keys of the documents in that collection. So to break that down, each document in the collection, in addition to its ID, must have one other data member in common, which could be its ID in theory, that is marked as the shard key. That shard key is hashed, and the hash of that is used to determine which shard in your application, or in your Mongo cluster, that data is going to be stored to. It's very similar to any other number of data distribution systems that I'm sure many of you have seen before. Shard key choice is critical because the shard key you choose is going to affect your data locality. In most cases, you want a query, for example, a select query, to pull data from a single shard so that you don't have to perform a bunch of scatter gather work at the Mongo cluster router layer. And so that means that you want to think intelligently about how your data is distributed and choose shard keys that are going to put pieces of data that tend to be used together on the same shard. There are some special case situations where you may not want to. For example, if you have queries that tend to use a lot of CPU power, and maybe you want to distribute the data, involve those queries across multiple shards because you're doing like a map reduce in database engine or something like that. There are some situations where you may want to do that. But in most cases, you want to exploit data locality and have the data that's going to be associated with a single query located on a single shard. So the way those shards are actually deployed is each shard is a replica set. I talked a minute ago about how replica sets are basically the building block of a Mongo cluster. So in a production shard cluster, you're going to have your Mongo router, which is marked as Mongo S there on the right. That is the query router. So your applications are going to connect to that to submit their queries. That router then maintains a mapping of all, essentially a metadata mapping of where all the data is in the cluster. That is stored on the config servers that are there on the right. That data is pulled into the router's memory on launch and is only modified in the config servers when you have to split blocks in the shard. So it's not modified constantly. And then it's going to distribute queries to the appropriate shard based on shard keys. And each of those shards is actually 3 servers, a replica set. So as you can see, a minimal deployment here can involve a lot of servers because you need 3 servers for every shard, you need your Mongo S, you need your config servers. So you are using a relatively large number of servers for a simple production level config. And speaking of production, anytime you do production, you probably want to make it highly available. So you probably want more than one Mongo S server. Now, there's several ways that people approach this. One common way is to actually put a Mongo S router instance on each application server so that each application server just talks to itself to route queries. That's one approach. Another approach is to place the Mongo S servers on their own systems and then use a proxy in front of them, or load balancer in front of them with stateful, that maintains stateful connectivity between the various application servers. That's the way that we approach it internally at Rackspace. And so anytime we, for example, deploy Mongo for a customer, we typically deploy 4 Mongo S routers behind a physical load balancer, or sometimes a software load balancer. And then we'll, again, distribute queries to the shards as appropriate. So that's the basic structure of a Mongo deployment from the server level. So let's talk about the interface. The interface to Mongo, it all comes from the document semantics that we spoke briefly about earlier. So a document has data members. Those fields each have a value. Those values may be simple values, strings, integers, floating point values. They may be lists. They may be other documents. So they may be compound or simple. And then you have a collection. A collection is just a collection of documents, essentially equivalent to a table. And so a database in Mongo simply contains multiple collections. So your database is your top-level container, then your collection is your mid-level container, and then you have documents in your collection. The query language in Mongo, in its native form, is JavaScript. So this is one thing that makes Mongo very easy to use for your typical modern application developer. JavaScript has become something of a lingua franca for most quote-unquote full-stack developers. And so JavaScript handily is the language of the Mongo shell. When you submit a query in the shell, it returns an iterable cursor, which is going to access the full collection of those records that were returned. In terms of writes, writes are atomic at the document level. So if you're performing a write and that write query modifies multiple fields in a document, it's atomic at that level, but it's not atomic across all documents that are written as part of the result of that query. Mongo, being a NoSQL style distributed database, doesn't contain true transactions, but you can do a 2-phase commit to sort of approximate that effect. And what I mean by that is that it guarantees that another query won't be interleaved with writes, but read queries might pull stale data partway through that transaction, or quasi-transaction, I should say. So you can see on the right that that's a pretty basic Mongo query there on the right, db.users.find. So that's your collection specification, and you're specifying your function, which is find, which is going to return all of the documents that correspond to the result. You're giving it a criteria, which is that age is greater than 18, and you are sorting based on age. So it's a pretty straightforward little query there. So you can see you have a collection, you have your query criteria, in this case a greater than. We might also specify a projection there, specify the particular fields that we're interested in, for example, and we are requesting the sort function be run on it. There are other functions as well in the shell, and therefore in whatever driver that you're using in your particular native language. So just to break down a query in a little more detail, here we've got a db.users.find here again. So that's our collection specifier. We're giving it a query criteria there by specifying that age is greater than 18. Greater than is one of the sort of reserved functions within the query language. There are many others. And then we're specifying a projection, meaning that we want it to return just the name field and the address field. So we're only selecting those two fields return. And then we're limiting it to 5. Now this may look a little bit weird, right? Before we saw the .sort function, this time we have .limit. You can chain those functions together because this is just JavaScript. So you could .sort, .limit, for example. But it may look a little unfamiliar to people who are used to SQL. But anybody who knows SQL can do NoSQL, because it's basically a pretty simple translation here. So this is a SQL query that essentially does the same thing. Select ID, name, and address from users. That's your table, which is just like your collection up in the other query, where age is greater than 18, limit 5. So you can see in this case that we are just grabbing the fields that we want. The SQL one specifies ID, whereas ID is always returned as part of a Mongo query. And we're getting that, we're getting it where it's greater than 18, and we're limiting it to 5 results. So pretty straightforward. Learning CRUD operations is not that difficult in Mongo, and if you have even a passing familiarity with JavaScript, it should come pretty easily to you. One cool thing with JavaScript is just since the shell is fully scriptable, I mean, you can write your JavaScript functions right in the shell to do a lot of things. In terms of language drivers, in terms of actually hooking it up to an application, there are actually quite a few officially supported drivers that are supported by Mongo Inc. C, C++, C#, Java, Node.js, Perl, PHP, Python, Ruby, and Scala all have officially supported drivers. If you're one of the cool kids that's doing a lot of multi-threaded work in Go, or if you're weird like me and like functional programming and want to do Erlang, there are community-supported drivers there too. There's always like one guy in the audience who wants to talk about Haskell. I don't know if there's a Haskell driver, so do whatever you have to do. There's always that Haskell guy. So MongoDB plus Sitecore, since this is a Sitecore meetup, we'll just mention kind of how it plugs in. Some of you may have deployed MongoDB with Sitecore already. There's basically two places that MongoDB plugs in with Sitecore. The first is the experience database, as Sitecore calls it, the XDB collection database. So this is a repo for contact, interaction, history, and automation data. And basically the reason MongoDB is used for it is over time, as this analytics data is gathered, you just run into scaling issues. It's just the reality. Especially high traffic sites, and as the amount of data that we're capturing more and more, you can only scale your SQL system vertically for so long, and it really becomes a real pain when you have to actually say change systems to scale even more vertically, or when you start having to decide if you're going to do, try to gain something with an always-on availability group and distribute reads across, and it just gets a lot more complicated. So Mongo provides that horizontal scaling and cost-effective scaling that's useful for this particular use case. And then the second is it's one of the two options for out-of-process session state. So that shared session state that you might want to put. The other one, obviously, is the SQL, but you can use this session state provider for that. I'm going to make you listen to like a 2-second pitch here. It's my tiny, tiny pitch. We at Rackspace run a product called Object Rocket, which deploys Mongo among other NoSQL databases in highly available, containerized fashion, 24/7 support. And this is like high-end, high-touch Mongo/Redis/Elasticsearch expert support. We have auto sharding, which is pretty cool. So if you have a configuration and you're concerned about scalability, we can auto add shards to your shard collections for you when you reach certain thresholds that you've configured, so that you don't have to worry about manually growing your cluster. We deploy everything on bare metal with containerization and PCIe flash for all storage. It's just a very, very high performance Mongo/other NoSQL tech deployment. So we use Object Rocket for customers for many customers who deploy Sitecore at Rackspace. It's just a really easy way to get Mongo without really having to think about it too much. So you don't have to think about deploying MongoS and MongoD and your config servers and all that good stuff, because we take care of it for you. Anyway, so that covers Mongo in general. So yeah, if you guys have any questions, I will do my best to hear and answer. It's a little bit difficult. Or if you want me to go back and talk about anything in particular. Sure. I mean, so there are different types of data stores. So Mongo is document oriented, so it has that very flexible schema, right? Every document you can have essentially a different schema in a collection. Cassandra is a wide column store, essentially. I mean, it's a little bit weird now, but it's basically a wide column store. Cassandra is different in that everything about Cassandra is designed for maximum performance and scalability. And what you sacrifice in order to do that is flexibility. So when you design a Cassandra configuration, up front, you have to think about what are the exact queries I'm going to do in my application. And then you design your data model so that you have a table essentially that fits each query. So each query has its own table, and each table has its own structure of the data. So you may end up with data duplication, but you end up with absolute maximum performance because you have structured copies of your data for maximum retrieval speed or write speed for each situation in your application. And I like that because it's fun. I like to help customers think ahead, design their applications, do data modeling, and deploy and get crazy, crazy speeds out of it. I mean, those capabilities are the reason that Netflix has more than 3,000 Cassandra nodes deployed, and why Apple has more than 70,000 Cassandra nodes deployed as part of the iTunes Store and Siri and all that good stuff. So what's that? Do you have to write more code to make that work? So you have to think a lot more. I mean, the reality is that Mongo makes it really, really easy to get started. You can sort of change your schema on the fly. You can do what works, and you'll probably get decent performance. One thing that I tell people a lot, and I'm going to switch to camera mode now if I can, because I'm going to use my hands, which I like to do. So I tell people that, like, when you do Mongo, it's like this is badly designed Mongo, and this is good, like, well designed Mongo. So like this is your performance band. Whereas like with Cassandra, it's like this is badly designed Cassandra, and this is really well designed Cassandra. So like you can do really, really bad with Cassandra. And if you do a lot of like really smart work, you can do really, really good. Yeah, it's very true. So that's I guess that's one reason why I enjoy Cassandra, in that I think that the customers that I work with also tend to need more help than with Mongo, for example, because they're going to rely more on my expertise to offload some of that complexity as they develop an application. I would argue that I think operationally, once it's running, Cassandra I think is easier to run operationally than Mongo, which is one reason why our Object Rocket platform is a good fit for Mongo, because it takes a lot of the operational complexity away from customers. But getting started, Cassandra definitely takes a lot more work than Mongo does in terms of your application side. I'm gonna throw my contact info up one more time. Just hit me up if you have any questions about any of this, or really anything else, data or Rackspace or not Rackspace, or I don't really care. Or people usually ask me how terrible it was to be in crunch time with Diablo for 2 years, and the answer is really, really bad. Diablo 3, yeah. Terrible. I quit before they shipped it. I was not responsible. All right. Thanks, guys.